when a charge moves in a region where there is a magnetic field, that charge is going to experience a magnetic force. That magnetic force is going to depend on the magnitude of the charge, how big the charge, its velocity, and the magnetic field. Now, if we have a charge represented by this yellow disk here that has a velocity v that makes an angle theta with the magnetic field b, the magnitude of the force acting on the charge is given by this expression. F is equal to Q, the charge of the actual charge, times VB sine of theta. Theta would be the angle between the velocity and B. We are talking about the magnitude here. To get the direction of the force, we use what we call the right-hand rule, RHR. And for the right-hand rule, for a positive charge, if Q is positive, we use the thumb for V. So here is the thumb, and then we use the fingers for B. So here is the rest of the fingers. So this is in the direction of V. This is in the direction of B. Then the direction of the force is the direction that the palm is pushing. Like in this particular case, if we are using the right hand with the thumb in the direction of the velocity, B in the direction towards the right side of the screen, our right hand side in the screen, then the palm is pushing down. So in this particular case, the force is pushing down. Now note what this equation tells us. If V is parallel to B, then the magnetic force on the charge is zero. Of course, if the velocity of the charge is zero, the magnetic force is zero as well. Okay, again for the right-hand rule, B is in the direction of the fingers, V in the direction of the thumb, and F is in the direction the palm is pushing, perpendicular to the plane of the hand. Now for negative charges, you can do it either of two ways. Either you assume that the charge is positive, you find the force and then take the opposite direction, or you just, instead of having the thumb along plus V, you have the thumb pointing along minus V.